Good evening to everyone. Okay, this is the Mastermind program. Actually, in this class, we are going to discuss about OpenCV with image processing. Okay, so first thing, what is OpenCV? Okay, we know OpenCV is open source library, right? So OpenCV is one of the open source library. So actual meaning of OpenCV is open source computer vision library. Okay, so this OpenCV library is one of the greatest tool for image processing, computer vision, face detection, object detection, and object tracking, and landmark detection, etc. Okay, we can implement this OpenCV using C++, Java, Python, and R programming language. So using this programming language, we can implement our OpenCV. Okay. Now we discussed OpenCV is one of the computer vision library, right? Okay, then what is the computer vision? Actually, computer vision is one of the field of artificial intelligence, right? So that enable the computer and the system to it derive meaningful information from digital image and digital videos and what are the visual input we give. Okay, it derive information from that input. So this is the computer vision. Actually, from the derived information, we can take action and recommendation based on its computer vision outcomes. So actually, this is the one of the best example for computer vision system. Okay, so actually this images represent the comparison between human vision system and the computer vision system. Okay, so firstly, see this image. So here human we have eye, right? So using our eye, here eye is one of the sensing device. So this eye only responsible for capturing image of the environment. Here we give one input to our sensing device. Okay, that input is nothing, one bowl. That bowl have some fruits. Okay, then after that, that information is captured by our sensing device and it moved to interpreting device. Here in our human vision system, interpreting device is nothing, brain. Okay, so that brain, what are the sensing devices, what data it's stored, all the data are stored in our interpreting device. So see this example, our brain is stored bowl, oranges, bananas, lemon and peaches. Okay, so the exact concept how human vision system will work, based on the same concept computer vision system also work. Okay, here for sensing device we give camera. Okay, so using this sensing device, computer vision system sends our input image and it gives that recovered data to interpreting device. That interpreting device store what are the information retrieved by sensing device, that store that content. So that contents are same, bowl, oranges, bananas, lemon, peaches. So this is the output of computer vision system. So compared to both human vision system and computer vision system, we got the exact output, right? So the computer vision system we can use it by replacing of human vision system. Actually, that computer vision system is widely used in our real-time applications. For example, one of the best example of computer vision system is our smartphone locking system, right? So nowadays everyone have smartphone, right? So in this smartphone system, we locked our smartphone using face lock and fingerprint lock system. Okay, so from that face lock, firstly we give some training to our mobile, right? So from that image, it learns something. That means what is the owner of the phone image structure. So those things learned by our mobile. Okay, then whenever we want to unlock our device, that time we show our face in front of camera, means automatically it check that face with our trained model and it will unlock. So this is the one of the best example for computer vision system. And like to fingerprint based locking system also based on this concept only. Then our snap editing, filtering, then watermark adding and watermark removing, those all are example for computer vision system only. Okay, then why computer vision technology is important today? Because using the computer vision technology only, we can transfer what are the knowledges our human have and what are the ability human have. Those all the things are we can transfer to our mission also. Okay, so that's why computer vision technology is nowadays very important. Okay, then come to our global vision marketing is exported to account on OpenCV. Okay, so actually computer vision is a rapidly growing field in research and application, right? So come to commercial growth of computer vision. So the computer vision is one of the proliferating and with the its demand for computer vision engineers that's soaring higher than ever. Okay, there are at present over 60,000 job posting along in US and that number is steadily increasing increasing in every year. Okay, so the top tech companies like to Apple, Amazon, Facebook, Google and Rockstar Games. So those all are looking higher professionals with the computer vision skills. Okay, so this fact clearly show that computer vision engineering job they hold great potential in 2022 and beyond. Okay, then consider research and novel innovations are happening in computer vision. So using the state-of-the-art machine learning technique like deep learning and convolution neural network, TensorFlow, PyTorch, etc. Computer vision will grow common surely as we like machine learning and data science and significant advancement. The use case of computer vision technology is transition of the public domain, and the computer vision applications are increasing and will see massive adoptions down the year within some years. Okay, so the digital image processing. So this image processing is one of the important technique in image processing is one of the important technique in computer vision. Okay, so actually here we give one input image, right? So once we send this image for processing means what we got in our output. So finally we got our output apple, banana, grapes. Okay, so actually digital image processing is nothing retrieving of information from our images. Okay, the next important technique in computer vision is edge reduction. So actually edge reduction is working based on brightness discontinuity of the object. So we can take any one image. So from that image, so firstly computer vision technique focus on its object. Okay, so once it search the object means before know about edge reduction, how that computer vision technique is searching that object in a particular image. Okay, so using deep learning algorithm, any classification algorithm like to CNN or convolution, that means CNN, convolution neural network or basic neural network. So like any one classification algorithm. Okay, so using that algorithm, so firstly it search the object in a particular image. After that, based on its brightness discontinuity, it detect the edge of that object. Okay, so actually this edge detection have two types. So one is Sobel edge detection and a Canny edge detection. So output of that edge detections are we can show in these images. Okay, the third important technique of computer vision is facial recognition. So actually, that facial recognition also, the facial recognition actually based on previous two techniques. That means the image processing and the edge detection. How means? So firstly, okay, our input is any one image or video. In case video means from that video it separate the video frames. Okay, from any one frame it detect image. After detecting of image, so it search the face. Okay, so based on that face structure it will give final output. That means that already we give some faces for training. So once we recognize one new face, mean that match with our trained data. Okay, then at the time of that face recognition, so more and more new data also will recognize. So that time the main task of this facial recognition is correctly find out our original face. So that is the important concept in facial recognition. Then so the facial recognition actually have another one types also. So using the Cascade algorithm also we can recognize face. So what is that Cascade classifier? Anybody know about it? So actually the Cascade classifier is one of the machine learning algorithm. Okay, so that algorithm will give necessary XML file. So from that file we can recognize our face. So actually this algorithm is mainly focused human eye and nose and mouth structures. Okay, you can saw that structure identification from in this image. Okay, so using this structure it will identify the human face. Another important one, land detection. Actually nowadays autonomous cars are available, right? So that cars are working based on this land detections only. Actually that concept is real-time implemented one. One of the best example of this land detection is our Tesla cars. Okay, not in our Tesla cars land detection is one of the part only. So apart from that more and more our computer vision techniques are included within it. Image processing, edge detection and traffic sign detection, object tracking and object detection. So everything are included in our Tesla cars. Okay, then object detection. Actually object detection is nothing. So before know about object detection, firstly we want to get some trained data about our object. Okay, so after once we have our trained data means, so we want to give any one image for object detection. From that image it accurately detect that particular image. For example, here we show here we can show one image, right? So from that image it can detect that image is cat or dog, like that. So it correctly detect this one is cat. So this part of identification is called classification. Okay, so once we classify our objects means, then we can do localization also. Localization is nothing. Here we can show one image, focus on second image. So within a boundary box we can show our object, right? So this is the localization. So second images represent classification plus localization. So this first example is single object detection. So use in a single image we can detect single object only. Okay, so this is called single object detection. Then another one type of object detection is multiple object detection. Okay, focus on this third image. Actually here in this image we can saw three types of objects, right? So one is dog and a cat and a duck. Okay, so using a single image we can classify three categories of objects. Okay, then focus on fourth image. Fourth image is nothing, so it give segmentation about the our detected object. So it segment the actual shape of our detected object. Okay, so this is called a multiple object detection. Okay, let me discuss about applications of computer vision techniques. So actually more and more applications are there, but here I take few applications only. So first important one is computer vision in manufacturing. So let me discuss about how the computer vision technique is useful for manufacturing industry. So based on it we can show one example here. So this is nothing, visual inspection of equipment. Okay, so actually computer vision for visual inspection is a key strategy in small manufacturing. So this vision based inspection system are also gaining in popularity for automated inspection of personal protective equipment. So such as mask detection and helmet detection. So those are also personal protective equipments only. Then that computational vision help to monitor adherence to safety protocol on construction sites or on in a smart factory. Then another one example for manufacturing industry. So this is the quality management. Smart camera applications that provide a scalable method to implement automated visual inspection and the quality control of production. That process and assembly lines are in smart factories only, right? So that hereby deep learning use real-time object detection to provide that real-time object detection to that provide a superior result, like to detection accuracy, speed, objectiveness, and reliability, etc. That's compared to laborious manual inspection, so it gives a better result. Then this quality management compared to our traditional machine vision system, this type of AI vision inspection that uses a machine learning method that are highly robust and don't require expensive special cameras and inflexible settings. Therefore, the AI vision methods are very scalable across multiple locations and factories. Okay, another one is based on health. Okay, so this is the mask detection. Actually masked face recognition that is used to detect the mask under protective equipment to limit the spread of coronavirus, right? So previously we nowadays every companies are implemented these techniques. So likewise computer vision system, that is that CV system, help that countries implement the mask as a control strategy to contain the spread of coronavirus disease. So for this reasons only private companies such as Uber have created a computer vision features. So this technique is based on face detection. To implement these techniques in their mobile app to detect whether the passengers are wearing mask or not. That program like this make public transportation safer during the coronavirus pandemic. So based on health department, we can implement more and more examples like tumor reduction, disease progression score, and healthcare and rehabilitation and medical skill training. Okay, let me discuss about tumor reduction. Okay, so actually brain tumor can be seen in MRI scans, right? So and that MRI scan and are often detected using deep neural networks. That tumor sorry, tumor detection software utilizing deep learning is a crucial under the medical industry because it can detect tumor at high accuracy to help doctors make their diagnosis, right? So these new methods are constantly being developed to heighten the accuracy of the diagnosis. So based on it, we can detect and diagnose every type of disease, not only this tumor. We can detect the skin cancer and cervical cancer. Like to that, we can diagnose every disease. Actually, another technique is based on agriculture. Okay, in agriculture field, how the computer vision is using in agriculture field. So we can use the CV system for animal monitoring and farm automation and crop monitoring, flowering detection, plantation monitoring and insect detection, plant disease detection, automatic weeding, automatic harvesting, and agricultural product quality testing, irrigation management. Okay, here we are going to discuss about automatic harvesting system. Okay, in our traditional agriculture, okay, so there is a reliance on mechanical operations. So with the manual harvesting as the mainstay, so which result in high cost and low efficiency, right? So yeah, that's only true. However, in recent year, with the continuous application of computer vision technology, high-end intelligent agriculture harvesting machines such as harvesting machinery and a picking robot based on computer vision technology, it have emerged under agriculture production, which has been a new step in automatic harvesting of crops. Then the main focus of harvesting operation is to ensure product quality during the harvesting to maximize the market value. So here the computer vision powered applications that include picking cucumber and picking apple, and it's automatically used in a greenhouse environment, or the automatic identification of cherries in a natural environment. So it can identify which one is good fruit or which one is in good condition. Like to that also it can identify. Yeah, then the next computer vision application is transportation. So in transportation, so where we can use this technique in transportation, we can use in vehicle classification and moving violation detection, traffic flow analysis, occupancy detection, and automated license plate detection, helmet detection, vehicle re-identification. So like to that, we can use this CV system for multiple traffic applications, right? Okay, here we are going to discuss about parking occupancy detection. So actually that a visual parking space that monitoring is used with the goal of goal of parking goal of parking slot occupancy reduction. So especially in smart cities, in smart cities, computer vision applications that power decentralized and efficient solution for visual parking slot occupancy detection. Okay, and that efficient solution for this visual parking slot occupancy detection based on deep learning convolution neural network, right? So there exist multiple data sets for parking slot detection, such as some models are available in net. So that's our PK lot and CNR part. So like to that, some pre-trained models are available to us. So based on it, we can develop this concept. That video based parking management system have been implemented using stereoscopic images. That means nothing here, 3D image. Using 3D image only, we can do this project with 100% accurately. We can detect that parking slot, or we can use thermal cameras also. So these types of camera add advantages of our projects. This camera based parking slot detection is scalability for large scale use in expensive maintenance and installation, especially since it is possible to reuse security cameras. Yeah, this is the dual advantage. That camera is little bit expensive only, but we can use dual purpose. Okay, then how the computer vision technology we can use in retail based applications? Anybody have idea about it? Okay, fine. So this is the example for computer vision in retail area. Okay, here this is nothing, customer tracking system. Okay, so based on customer behavior analytics, we can track our customers. So using the deep learning algorithm only we can implement this concept. So the deep learning algorithm can process the video stream in real time to analyze the customer footfall in retail stores. So the camera based methods allow reusing the video stream of common inexpensive security surveillance cameras. So here the machine learning algorithm detect people anomalies and contactless to analyze time spent in different areas and their waiting time and the queuing time and assess the service quality. So this customer behavior analysis. So using this system, it can helpful to improve retail store layout and increase customer satisfaction and objectively it quantify key metrics across multiple locations. So not only this customer tracking and the customer behavior analytics, so we can actually within the computer vision retail, we can include the people counting, theft detection and waiting time analytics and social distancing. So this one also comes under these types of applications. Okay, not only in medical field, in retail field and agriculture field, so that AI system we can use for sports also. So how means, so this is the performance assessment. Okay, so this application is useful for sports players. So actually that automated detection system. So we want to implement an automated detection system. So it recognizes of sports specific movement that overcome the limitation that associated with the manual performance analysis method. And so that methods are subjectivity and quantification and reproducibility. Okay, so here the computer vision data, that the data inputs can be used in combination with the data of body worn sensors and the wearable sensors. So popular use cases are swimming analysis. Okay, so swimming for the so actually that real time applications where it will give a high recommend in swimming analysis and golf swing analysis and overground running analytics and alpine skiing and the deduction and the evaluation of cricket bowling. Not only this, Then we can use this type of system for multiplayer post tracking and stroke detection and real-time coaching. So like to that we can use more and more applications. Okay, this is the example for watermarking. Okay, so using our computer vision technique, we can add watermarking. Actually, this is our main image. So this is the logo for watermarking. So we can make watermarked image using our computer vision technique, and we can remove watermarking from our actually we have anyone watermark the image means we want to remove that watermarking means that's also we can do using our computer vision technique. Okay, actually self-driving car. So the self-driving car, actually Tesla cars are, everyone know about Tesla cars, right? So that is one of the autonomous cars. So that is called a self-driving car. So how the Tesla car will work? Okay, more and more technical included with it, but the main technique is AI and OpenCV. Okay, here that major part of to computer vision concept is one is the land detection and object detection. Already we discussed about this land detection and object detection, right? Then behavioral cloning. So based on that traffic light detection and where we want to cut that road, based on it automatically it can choose its path. Okay, so this is one of the major advantage of self-driving car. There is no need to driver. Then one of the main capable of this types of car is self-learning, and it also have the capable to decision making. Okay, actually now we discussed about that more and more applications of based on OpenCV, right? Okay, actually, so this is the one of the detection algorithm. So based on land detection, we can detect that car. Okay, so actually here what are the concept we included mean region of interest. That region of interest is will give where the car we want to drive. So if we, for example, you can take Tesla cars, the without a driver the car will be drive, right? So here we want to deduct that path, right? We want to deduct land. So for that purpose here we are using region of interest and edge deduction methods and the probabilistic of transform, that is one of the filter method, that's also here be included, right? Actually this video is one of the demo for Tesla car working. Okay, here this using this video we can calculate the ego speed, timing and vision type. So everything we can get. So based on traffic sign and based on that pedestrian line and land detection, that car will automatically make decision. Let me see about some real-time example of computer vision. Okay, so one of the important example of computer vision technique is real-time fire detection using OpenCV technique. Actually we know about fire detection, right? So using IoT technique we have some fire detection or smoke detection sensors. Using that sensor we want to connect that sensor with any microcontroller. So after that any smoke or fire is detected mean it will give some alarm sound, right? So okay, without any hardware, okay, without any hardware, only using a camera we can detect fire, right? So let me discuss about it. Okay, actually necessary libraries are firstly here I imported. Okay, we know about the NumPy. NumPy is actually used for used to reading a multi-dimensional array, and we can read image also using NumPy. Okay, then and then next here I imported CV2 library package. Okay, CV2 is nothing, computer vision library package. Okay, so using that computer vision only we can read out our videos, and we can read out that videos and images, everything. Okay, after that, after importing important necessary library packages, then we want to read our system camera, right? So using our computer vision technique, here we read our camera. Okay, the cv2.video capture that represent the camera. Then after that we want to read our original frame. So for that, using the read function, we read out our original frame. So after that, here we did color conversion. That's mean the BGR to gray conversion. So once we deducted our frame, means that frame we convert BGR to gray. Okay, actually how this fire deduction will work means nothing. Using Cascade algorithm only we did this project. So actually this Cascade classifier, okay, so this Cascade classifier working is based on HSV color deduction. Okay, so actually fire deduction XML, that file we have. Okay, then after that we want to convert our frame into HSV format. HSV means nothing, hue saturation value. Based on colors hue and saturation value, it will deduct our object. Okay, now in front of our camera any fire is deducted means, so automatically based on its HSV, that means hue saturation value, it deduct that particular object and compared with our Cascade file. Okay, that both things are matched means it will give alert fire is detected. Then after that, one wins that's mean using Winson, we attached one beep sound also. Okay, so now fire is once fire is detected, and beep sound also we got. Okay, so what is the next level of this concept? Okay, now we want to send that fire accident locations and level of fire. That's also we want to share to any fire stations, like to that. Okay, for that we want to capture that location, and we want to send to any particular office mail ID. Okay, fire station mail ID. So for that, using SMTP protocol, here we added our Gmail ID, and here we define one mail function. So it gives it give a fire alert to that particular station people. Okay, and we can send this type of message also. Any one particular office we consider we can send this message to that office management or any fire station. So like to that we can use. Okay, to run this type of project, I use Anaconda Navigator. So here I give a click environment. Okay, actually necessary packages are already I downloaded in this new environment. Okay, so how we can create the environment using this Anaconda Navigator? Simple thing only, just go to create. Okay, so you just give create means it has the environment name. You can give your own name, and you can select Python version also. So different types of versions also available. What version you want, you can choose that version. Okay, so then you can give create. then successfully environment we can create. So after okay, here already I have environment. I just to open this environment. Okay, after that I give open terminal. Okay. Actually here my environment is opened in C colon only. Okay, then my project also in same location, same colon. So I just copy the path of my project, and here I give current directory cd space my path. Okay, then next, actually the main Python file is here, that I put the name fire, right? So here I give Python space fire dot py. Now I just give enter. Our camera will turn on automatically. Okay. I just show fire in front of our camera. In front of my camera, I show fire. The sound is automatically came. So after that, we can check our mail. So this is our mail for particular particular management person or anyone fire station person. The message is sent like to this image attachment, and any content we want to add our location, anything means we can add with our mail. Okay, so this is the I think this is one of the best method to detect fire without any hardware. We can simply detect real time fire, right? So another one of the best example is mask detection. Already we discussed about it, right? Yeah, that same concept only here we are going to implement. Actually, for that mask detection, for the training of for the training part, we collected some data. So one part is with the mask. With the mask, some data are I collected. Without mask, some human faces. So that data also here I collected. Okay. So after that, I just open my Python file. Actually, here we are using MobileNet model. Okay, so not only MobileNet, in the computer vision system, for the object detection and object tracking, everything. So for that we use some models. Those are MobileNet, YOLO. YOLO means you only looking once. In YOLO we have YOLO V3, YOLO V4, YOLO V5. So like to that we have some models. Okay. So here we use MobileNet V2. Like to that MobileNet V3 also available. Okay, so actually in first part we imported our necessary library package. So after that we want to predict our mask, right? So firstly we declare our frame. So after once video frame is detected means so it capture a image. Okay, so image is captured means so after that it compared to our trained model. So once that face is detected with our masked face me, it's shown mask is detected. Otherwise it's shown mask is not detected. So here only we read our frame. Okay, so then after that uh, that means face is masked means it's shown face is masked. Otherwise no face mask detected means it's shown no face mask detected. So this is so actually this set of codes are we are used for designing purpose of our video frame. Okay, so I want to put that frame name is COVID-19 face mask reduction. So like to that we can change this string also. Okay, actually I kept this set of code in local disk D. Okay, so that's why in my Anaconda Navigator environment I give D colon, and after that I give CD space, and I just copy my path. After that I give Python. Here my main file name is, detect mask video. So I just copy this name and I give here, and I give .py. So now video streaming is started. So I didn't wear any mask, so it's shown no face mask is no face mask. Okay, so then I wear mask. Now it's shown face masked, right? Do you have any doubt? Please put in chat back. Anybody have doubt? Please put in chat box. Thank you for all the viewers, and thank you for coordinators, and for any project support, any project help needed means please contact our office. Our online stores number is here I mentioned, and Chennai, Hyderabad and Vijayawada, Kovai branches numbers are I mentioned here. So any project support you needed means please contact our branch. Okay, so thank you to everyone.